Okay, so welcome back to Cloud Computing and Big Data. Today we have our lecture 13 on OpenStack Cloud Operating Systems. The first part of this lecture basically introduced us a little bit about the idea why OpenStack is useful. You have a lot of common ideas how clouds actually being built, and we learned a little bit the idea of shifting the view. Now, when you basically tasked to create your own cloud on-premise that ideally should be also interoperable with public cloud offerings like Amazon and so on. By looking deeper in Amazon, we basically looking, for instance, just as an example of a cloud in terms of computing service into EC2, and we need something scalable that we basically found a little bit in the Nova services. And you go on and think about the S3 interface. We talked about Amazon in terms of different storages, object storages, block storages, file storages. So all of that needs to be basically developed also from the software infrastructure. Needless to say, you have the hardware underneath that should be always there if you want to create your own cloud, obviously. But in order to manage all these shared resources, and this on top of it in a kind of way of scaling it really to the amount of users, having some auto-scaling behavior, using the power of virtualization, all of these concepts needs to be implemented by you. If you don't build your, let's say, applications, your organizational cloud or whatever it is you want to basically provide with this cloud, if you don't build this with OpenStack. So the OpenStack is a way of de facto standard today of having components readily available in the open source domain in order to put together your own cloud. And it could be these different layers that we discussed in the first part of the lecture, also continuing also what we had in the last lecture, being able to deploy containerized services even with a XAMPP service. So needless to say, OpenStack can save you lots of development efforts of maintenance, sustainability problems that you basically have if you don't use your OpenStack components. So here you're really kind of encouraged to look at this before you potter off and create your own cloud components in terms of software, because chances are OpenStack is just good for you. So in the second part, however, in this lecture part today, we also want to look at some higher level services. So how are people really putting together these different pieces? And it should show you not the solution always alone. It should show you how it is, again, like a sort of big Lego brick, let's say, repository of different services that you can combine in order to solve different problems that you often have in a typical cloud that maybe your boss or your customer wants from you. If you're an IT organization, if you're basically the IT department of a large company, you're basically in the same situation often of creating different parts that are reused again and again. And by implementing these parts with OpenStack, you have, let's say, a very lively open source community. We learned in the last lecture also that basically OpenStack is one of the top level open source components these days. So chances are that there will be basically lots of good new versions coming along that you can adopt and then skip all the development efforts, and it comes and boils down to the idea of combining these services smartly, configuring them wisely, really to bring, basically these components to a higher level service or a higher level goal, really. I think one of the higher level goals is basically the idea of using them jointly to serve a specific purpose. And you see here what we basically have in this particular slide. All we want to basically provide here is a VM, a virtualized, kind of infrastructure that is able to work with a VM that we then can use for all sorts of applications. And in order to realize that in a cloudish way, also being able to scale around your clusters is basically shown here in this particular slide. So one key is, of course, having firstly all of these images where you have, basically Glance as a service that you can use to basically store images that can provide images, which basically brings us then to the VM. We know basically in order to get to the VM, a VM has to run somewhere. So it's not all about the storages and the images where it comes from. We also have to think about that this should be instantiated and really running somewhere. Hence, with all that, we also have the Nova service, which is our compute service that provisions the VM, really giving cycles to the VM to be ordered, basically then of magnitudes in replicated or work on different computing resources. So here it's a very important part to think you need all of these different components, one more than the other, to really get a VM up and running within your own cloud. And then you can add several different services. You can imagine that with Cinder, we need some certain way of having storages. We had looked at the service before, so it provides the volumes for the VM, but also backups the volumes that you basically have in Swift, which is another, let's say, type of storage service. We have some certain ideas of how we basically also thinking about monitoring all of this with a silo meta component here. We have even an UI that you can bind to it in a standardized fashion to see some statistics, to see the monitoring of your infrastructure in real life, so to speak. And then you have, of course, overall idea of security, of really who is able to access all of that and works with these VMs, which should be, of course, for instance, just constrained maybe to the members of your company. And the more you thinking about making it bigger and scalable, you can imagine that you need some help, especially if there are more VMs available. And of course, some of them maybe want to interoperate or having access shared part where they want to access the same data. It really depends, of course, on the application and what you want to do with this kind of VM setup you see in this slide. But you also want to see that there is a specific way of how to trigger then the scaling. And for this, there's another service called Heat, for instance, that is able to scale all of these orchestration component parts if you want, including network, including storage, but then also most notably the computing unit. Hence, we need several of these components, and you would say that this, what we see here today, in this particular one, in this particular slide here, is one of the most de facto ones which are often used for different virtualized applications. But still, you remember, Sun and others had still some containerized images to offer. So it's not the best practice, perhaps, but it's still the one often used. When it comes to best practices, though, with larger cloud deployments, and here we talk about that your boss will say, well, we don't want to have a tiny cloud here, we want to have a bigger cloud, right? The whole cellar full of computing, then you need really help. You need something that is orchestrating really these all of type of applications. And you will see also that basically the cloud is often run by Kubernetes or these orchestration engines in combination perhaps with containers, as we had also discussed the last time. Hence also OpenStack supports this paradigm of using not only Kubernetes but also containerized applications, what we want to do in order to really basically leverage the cluster. And this is something where OpenStack has several different components that you can use for making it happen. And you can go on and go on, different web applications you can use in terms of just more or less creating your own websites. It could be also more repositories, upload and download services of our image, application that we discussed in one of the lectures. So here it's quite a flexibility how you combine all of that. But as you see also is often that Nova computing is often a big case because you really need to compute somewhere. But then you have also the idea of security and different constructs. And, of course, it's storage part that we should not forget with a Cinder volume. There are different types of applications that this slide should suggest. I think the big data one is the next one, where you already heard basically part of one previous lecture, the idea of using a master-slave architecture, they basically, or master data architecture as it is here in particular, of being able to scale to larger problems really. And also here, you still have the point that basically you need, so to speak, Nova compute services. There's a specific name node and Ambari, which refers to Apache Ambari, which helps a little bit with the idea of running Hadoop clusters and running these clusters today that I cannot cover completely in this lecture, but we'll make a short glimpse in one of the subsequent lectures on it. So there's huge room also to combine it with other open source services. Then we had, of course, a neutron service again here in the data security group. Think about cluster networking, and then basically having an admin view on it, where you, of course, again think about how you can steer this cluster up in terms of masters and workers, in terms of coping with big data. In terms of e-commerce, this is a different story. So also there you have a different application domain, and it shows you more about the analytics that you want to do really with e-commerce. But still, the idea is thinking about what components we really need. And here you have a user interface. We talked about this already, but also, of course, Nova Compute is again very promising and really adapted in this use case as well. And then, of course, thinking about the load balancer component that we discussed in terms of depending on the number of users really using your e-commerce website. And then basically have an image store that helps you with the kind of service offering in the e-commerce. And all of these components now here are basically something you can pick out of this OpenStack component repository and make it and instantiate it as part of your service offering. So again, there's some of these services, the core services, if you want, like Swift, like Nova, always being used. But this slide suggests as you know, perhaps a little bit on the Lego analogy, that these could be combined in different ways. And then with this have different configurations, different ideas of using applications. So when you think about the MapReduce programming model, this is another idea how basically this predefined ideas of components can work. We discussed this in one of our earlier lectures, this idea of having map, sort, shuffle, group, and then reduce. And you have these different types of nodes that we really need in order to deploy such a cluster like this, depending on the name node, which capture all the metadata, but also compute and storage again. And this is something which is already supported basically on OpenStack and also by some repositories where the master and slaves can be, so to speak, instantiated with node managers, resource managers, the name nodes, the data nodes that we already know, that we can then use also, for instance, for some nice applications, like we use for frequent pattern mining in one of the last lectures, or for some parts of the Spark ML library. Hence, building such a cluster with OpenStack is actually not that difficult, especially if you are in charge of your own company and you have some physical resources already. You basically have to make sure that you just have the right setup. And this is, for instance, here a very simplified right setup where you would have a master with a name node capturing all the metadata, if you remember, a resource manager in order to be able to allocate resources to different users, to keep track of the execution of all these different services, and then basically schedule all of the kind of users that you need in your clusters, for which you need a node manager, but also need the idea of a characteristic of a data node. And if you go to the left side of this kind of slide, you will realize that essentially many of these components are directly uses something which is already available really in the OpenStack framework, like Nova for the resource manager. You have the name node, if you remember, it computes something, but also stores the name and metadata around in the cluster. So you need a Cinder, and basically also then the node manager and data node uses both Nova, while the data node, of course, has also some storage characteristics using, for instance, Cinder. So this is kind of different components in the OpenStack repository. Needless to say, you have to really configure them first to work together. So just throwing them in each other, deploying them one by one in one application part will not really work. So they all have to be basically then configured properly in order to solve a higher level problem. Now, when you look at this, you can see the sample configurations here as an example of how you can combine them really in more or less a production scenario, where you also have to think about lots of monitoring metrics, where you show a little bit about how much is the uptime, how many users you support, and things like that. If you see on the lower part of the service offering, kind of Apache Ambari idea of deploying such a kind of Hadoop cluster and computing cluster. But alongside are, of course, many interesting, let's say, environmental tools which are important for security, which are important also for different parts of your organization, who is allowed to see what of the cluster, hierarchical management, where it says like who has really access to which part of the clusters. This needs to be also part of the problem. And then when you think about the Apache Ambari project, this is really an automatic way of doing this big data cluster provisioning, where we basically request rapid deployments in order to make it happen, and where you basically have the same idea of this kind of service and idea of using this in a flexible way, where you basically can have, for instance, some interesting, let's say, Hadoop clusters very easily create with the Apache Ambari, scaled up and down, and manage the whole cluster really. So this is where basically Ambari is quite good for. And you really want to do this, and not start from scratch, building all of these pieces, but rather download some of these components that actually then also OpenStack environments can provide. So very interesting material, very sweet material. Still, we could talk about this a whole week, how you really configure then edge nodes, Ambari name nodes, and Nova compute nodes, and so on. But still, take away the message that even security components are quite well addressed in this framework. But again, there is also the point, you really have to configure them to your own need. So the own need, as I was alluding to, is of course often represented by some API calls, or the way how you actually use the whole idea of cluster or the shared resource. Could be, of course, then also leading towards software development kits that you call different functions during the execution of another software, and you just resume with having the answer of those. And the whole idea of using APIs significantly in the clouds is, of course, there as well, where you always think about the service capabilities. If you then add the kind of container philosophy, you often would talk exactly in that context also to microservices. So what are the microservices you kickstart via APIs to solve a very mini problem and come back to me? So this is a very interesting approach as well. So, and OpenStack provides services for all of these different entities. Hence, there's also a wide variety of products, solutions that really adapt this particular technology. We have the Open Telecom Cloud that is basically in the OpenStack marketplace, giving you access to public resources. We have different consultings that basically offer you help when you have to deploy your own full suite of OpenStack services in your company, like Red Hat or IBM here as an example. And then there are, of course, virtualization providers that also think that the world of virtualization and of kind of these containers really need to be combined, and of resource provisioning. Hence, you have also VMware as a strong player in this particular context that is basically offering lots of these solutions. So OpenStack, as you see, is now something which is really broadly adopted. There's an own marketplace based just on OpenStack, let's say, application and possible partly shared components by the community. So from the e-commerce industry, one business case for OpenStack, which is just one application example, is basically the idea of using it in retail and e-commerce, like in eBay, Walmart, Best Buy. These are the kind of services where you can basically work with. Here, the idea is really thinking about differently combining, again, a lot of different services from basically the idea we had before with OpenStack, taken perhaps a regional approach of saying divide and conquer, and then basically download basically overall global load or global statistics in this part. And the names you already know, like Swift Storage, we discussed. Basically, the Cinder we discussed as well, Neutron, Keystone, you go on and go on. And basically, this is, of course, something which is always required. And with this, there's specific kind of OpenStack components for it. And here, the idea is really thinking about multi-tenant, multi-region, self-service cloud. So here, this is the idea of multi-region. You can just instantiate, as you see here, with region A and B and C, with different instances, because we still kind of the idea of a kind of abstract layer on OpenStack where you can easily create new computing services and service offerings. One of the examples I want to show then in that context is basically adopting some of these components for very popular applications. And one of that is probably something what you see from Blizzard. There's a very nice application video, if you want, here available when you watch the video of Blizzard Entertainment. And here again, the idea is thinking about lots of users that you don't want to really track a number of users on a, let's say, minute basis in order to scale up and scale down the cloud. Hence, automatism to the rescue. So here's the idea that, for instance, in this kind of game that you see here from Blizzard, this World of Warcraft and so on, and many other games actually, they basically running in the cloud and basically have a super use case, so to speak, for this auto-scaling behavior. It depends on the number of users. It depends also on the kind of region, or if you want also the kind of ceremonies that you have there, let's say around Christmas, for example. So obviously it depends on different factors. But also, if you think about then how you would realize it, it's actually not that hard. You have still the compute entities, which we well know, and there's an idea of auto-scaling to be basically now added to this basic components that we had already in order to understand how basically then also game makers and many other applications can gain secure and scalable access to this particular part of the cloud. And some ideas why Heat is quite successful. You see basically the idea of using different services for scaling out, for auto scaling that we will see here today, for these different examples of Heat and Zenlin. And why auto scaling is a very important point. Of course, here we want to save resources. You see basically the idea of VM3 and VM4 is quite idle and unused. When you think about, you characterize the load a little bit. So that means we can block the resources for some others. Hence, here we should really give it free as available capacity. And this is something where you would say, traditionally you would say, deployment should always look like the VM 1, 2, 3, 4. But you see here also it doesn't really are leveraging the efficiency of the VMs because nothing is really done. Hence, we probably can stop this and mark this part available for the whole capacity for another part of the problem. And this is the idea of this auto kind of scaling, but then also on top of it, the malleability, like for instance in the Admire project, or elasticity, if you want, from the scheduler, that then is able to use this available capacity if you want in order to do game B happening. So very interesting, and give you also some, kind of pointers of numbers. Just think about the Overwatch application that you see here. This is a person ego shooter, which doesn't really matter for us. But think about it that it has 40 million registered players globally. Again, think what it means if you have 40 million registered players. In a way, you would say it's a good business model. So, I mean, having 40 million users, that's excellent. But on the other end of the scale, you would think, they really need a game service which are, really perfectly optimized, which are available 24/7 in the OpenStack environment. And with this having a unique, let's say, case of saying, with all these different users, we need something to auto scale up and down, depending on basically what's happening with the cloud. And so this is another example of a company that uses OpenStack, and in particular also the auto scaling behavior. And this is pretty noticeable because it's still a gaming company. But there are other application examples in terms of auto scaling. How this really works in the Zenlin and Heat setup is shown basically in some of these graphics here, where you basically have Zenlin creating service if needed based on the Nova compute services. They, of course, create the VM. that we need in order to basically create a bigger, bolder game cluster. And then the autoscaling service will monitor if you have to scale up, or basically, as you see here, if you have to scale down. If you want to scale down, we basically pick one of these services and delete the server, which is then basically sent from Zenlin, and basically then give some statistics and lifecycle information to another service. What we, of course, in the moment don't really hope to engage in, by the way, but this is something, of course, which is modus operandi in almost all cloud applications today, of this auto-scaling. Now, thinking also about the more academic world, when we talked about the European Open Science Cloud, this is also something related to this aspect, where you have lots of these different components, and many of these service offerings are actually created or basically derived, at least, from the OpenStack idea of creating cloud service offerings. And one of those parts is basically HDF Cloud that you already use during your assignment right now. So if you open it with your normal username and then your password, you will have noticed that in the files there's also some pointer to some basically publication, talk, or reference that we have inside here. And of course, it's part of your assignment. So here we also have to not explain everything in perfect detail. Just take away the message that in order to create this idea in the HDF Cloud, we also use the idea of basically OpenStack. That is then, of course, combined with EOS service offerings, which we have in the EOS Cup. So lots of these different pieces come together. And when you basically activate the kind of assignment parts and you basically open then the kind of GUI, then you basically see directly the interlinks of all of that, because you have a B2Drop service usually you can pick from. And this is more or less parts also of your third assignment, so I will not talk about too much in detail about this, but think about that. Of course, here we have the same problem where the Helmholtz Data Federation is one organization, and the organization needs its own cloud. Hence, we are in the same situation that I said to you in the beginning of the course hours today. Your bosses want to have a perfect infrastructure. You see here we have several geographically dispersed members of the Helmholtz Association, where we basically want to have all access to this Helmholtz data cloud, or the European Open Science Cloud for Helmholtz services. So here you have also the idea why they would basically build then this on OpenStack, in order to provide these services not only for your own organization unit, which would be the Jülich Supercomputing Center here, but also for your larger organizational parts, basically split different geographically dispersed regions. Hence, a good example of a cloud and a good example of how OpenStack can be useful in order to create our own cloud. And this is something what you already experienced during your assignment. And I mean, there's no basically small surprise to think about what services are needed, right? So there's a Nova service for computing again, even if it is in JSC, still we have some physical resources, that's all good. But in order to really compute on these resources, we need a computing service, which we then of course have with Nova available. Then of course a big element of one of these centers in these kind of Helmholtz Association would be all about security. So basically Keystone is an identity and catalog service for OpenStack that basically provides authentication systems in order to get to the right people that are using this infrastructure. That is based on LDAP and also B2 Access, and our request that we had before of really getting an account at FZJ or at Jülich. So this is an interesting aspect, especially if you have to scale out, especially if you see what this suggests in terms of the majority of services or many of the services being addressed just maybe with a small little kind of line. And here you have a core management infrastructure where you say at least in the academic example that we would have in the Helmholtz Association, there we have different resources we can connect to with the compute nodes in Eureka, Jewels, but also UDAC and many others that actually nowadays also deployed. And then also the HDF cloud, which is largely built on VM resources in order to basically get access to cloud services and computing. There's lots of data exchange. If you think about the deployment in detail, we're just going over the file systems area, while the upper layer is definitively looking into the cloud deployments and what is possible there. And this is a tight interconnection with some of the EOS services we discussed earlier, like the B2Drop services, which are basically a Dropbox for scientists. So talking a lot about all of these services, and I think by now you have gained the idea of why OpenStack might be quite useful to look at. And I just scratched the surface really with all the different services, and all of them have different configurations and possibilities to be configured, so that this is a rich environment that you always should check before you create your own cloud. I mean, basically, these are components which stand the test of time. It is an open source community that is very strong, and chances are there's a component that you can really need in practice in order to make your customers happy. In order to summarize a little bit what I talked about now, and basically could continue to talk about for 2 or 3 days, really, as I said, OpenStack has many different components. We just picked a couple of them here to show you that there are components that help you in the development of your own cloud. And basically, if you want, OpenStack is so to speak the de facto standard on that. But here I have a small video for you as a summary, how you may be also integrated with virtualization solutions.
What is VMware Integrated OpenStack? Before answering that question, let us take a look at OpenStack. OpenStack is an open source framework for delivering cloud-based IaaS. OpenStack provides applications with API access to cloud services. It is best suited for cloud-native applications that are specifically designed for cloud computing environments, as opposed to applications that are simply being migrated to the cloud. As a cloud operating system, OpenStack controls large pools of compute, networking, image, storage, and other resources throughout a data center. The OpenStack APIs simplify the consumption of virtual infrastructure technologies. OpenStack itself does not provide the virtual infrastructure or a majority of cloud management functionality, such as monitoring, troubleshooting, policies, and governance. In VMware Integrated OpenStack, VMware Software-Defined Data Center, or SDDC technology, provides the infrastructure. Familiar tools like vSphere, NSX, vSAN, and vCenter interoperate seamlessly with OpenStack, making it easier for IT groups to run a production-grade OpenStack-based deployment on top of their existing VMware infrastructure. It provides simplified installation and optimized management provided by vRealize Operations, Business, Log Insight, and Automation. VMware Integrated OpenStack is the best of both worlds, enabling IT admins to easily deploy and manage a production-grade OpenStack cloud on a rock-solid and feature-rich platform.
So that was a very short summary, how you actually can use that on top of virtualization. This was now, of course, based on VMware, but that doesn't have to be that way. So basically, of course, as I said earlier in many different lectures, I'm also not paid by VMware. But of course, there's an idea of leveraging all what we had before in different lectures, like virtualization, abstracting from resources, enable resource sharing, enable a better resource utilization. But then on top of it, you have to manage all of that. And in order to do this, you have this OpenStack components, which on top of it even provide you a very nice API to really then use it in your applications in order to make basically your applications feel like there's an infrastructure as a service as professional as AWS services or MS Azure or Google Cloud, but it's actually in your own basement. Right? And this is the idea of that I wanted to leave you on the table here today, which is really thinking about creating your own cloud components, your own service offerings by reusing some of these OpenStack components. This requires, however, diving more in the details of all the different OpenStack services around. We discussed Nova, Cinder, and many other services which are important, Heat for orchestration and so forth. But obviously the OpenStack API and the OpenStack component collection has much more services to offer. Like we discussed already with the Sun containers, this is a huge set of software which needs to be investigated in order to think about what could you leverage in order of magnitudes from already components created that I just have to put together in the right combination and configuration in order to solve the goal that I had as a task within my own organization. And we stop here basically on OpenStack. And needless to say, this usually requires 3 to 4 days, just like hand-on examples, how you do this in practice, what we cannot deliver here at the university courses. But if you are interested, there are different courses out there that really give you more details on OpenStack. So we stop here and see you next time in basically lecture 14.